Hello, my name is Kaji from Section C, Professor Parker, and this is my video for Physics Lab 1 of constant velocity. For introduction, the purpose of this experiment is to observe the motion of an object that is moving with constant speed without changing direction and comparing this motion to a predicted computational motion. And the object I chose was a basketball, and this is the preview of the experiment with a blue dotted line representing the experimental position and the solid red line the model position. Some fundamental physics principles to know is Newton's first law of constant velocity motion, in which the net force of an object is equal to 0 if it's standing still or in constant velocity. In this case, it is in constant velocity. The velocity update formula, or Newton's second law, which we're going to set the net force to 0. So V final is going to be the same as V initial because the velocity is constant. The position update formula with average velocity. And some assumptions for this observation is that drag, friction, and changes to the axis other than the x-axis has to be ignored. This is my tracker analysis. As you can see, I put an origin and a center point mass of the ball, and the tracker tracked all of the coordinates and plotted a graph with a positive slope. The system was the ball and the surroundings were the table. Some initial conditions according to the screenshot of the tracker. The initial position was 0.0024 meters. Of course, we're ignoring the x and y axis. We're only caring about the x axis. The initial velocity we calculated by subtracting the value of the x axis in the second timestamp, which was 0.033 seconds to the first one, and dividing it by the change of time, which was also 0.033 seconds, and we got 0.006700 meters per second. The mass was 0.325 kilograms, and the total time was 1.233 seconds. And the frames per second were 30, which explains why the timestamps are separated by 0.033 second intervals. This is my closed script code. We can see that I changed the ball's mass to 0.0325325 kilograms, and I changed the ball's position and velocity according to the values that I calculated above, and I changed the time to 0 and delta t to 0.033 seconds, and I changed the max time to 1.233 seconds, which was the max duration of the experiment, and I changed the net force to 0 because, again, according to Newton's formula, we want the force, set the field of force not to be 0, so it still is in constant velocity. And then I also changed the velocity and the position of the ball and put the formulas according to the equation I just showed. This is the predicted versus the experimental graph analysis. The blue dotted line is the experimental position, and the solid red line is the computational model position. We can see that both lines, they have similar slopes, but they eventually are going to diverge because we did them in different conditions. Both lines appear similar in the beginning, but they diverge. Some of the reasons is because in tracker there might have been human error while estimating the center mass point, the origin reference, or the calibration stick. And in GloScript, something may have happened when I ignored friction or drag in the code. There's also the possibility of the basketball curving during its trajectory. We might have affected the changing positions in the x-axis. And also the divergence can mean that there are other external forces acting on the ball. Now, what if I made the choice of changing the orientation of the axis? I rolled the ball from left to right, but what if I had done so from right to left? So the results would be similar, but they would have negative outputs since the ball is going to be moving in the opposite direction of the orientation that I had chosen, which means that the slope of the line would be negative and it would point downwards. However, the absolute value of them would be similar. Is it possible to tell how many pushes and pulls or forces are added to give a zero net force in the experiment? And Newton's first and second laws, they actually don't tell us how many interactions there are in a specific situation, so we can't. And because there's a possibility of more forces than the ones we accounted for in the experiment, which may have affected the recorded position and velocity. However, we are certain that the experiment shows the gravitational force of the Earth, making the ball make contact with the table. In conclusion, in this lab, I used Newton's first and second laws to predict the motion of an object at constant velocity in one direction. I used tracker to determine the center mass point and other conditions, and to simulate the movement of the basketball and calculate its velocity using the code in GloScript, and having both models, I compared them and discussed the differences between them and their possible causes. Thank you.